Right, good morning Year 9. So today we are looking at nanoparticles, and I was going to look at polymers as well, so I started off writing polymers, but we're actually just going to look at nanoparticles because for polymers you need to have an understanding of hydrocarbons and crude oil, and that comes in another topic. So we are just doing nanoparticles. So what we'll have a little look at, what they are, some example questions that you might get asked, and then your task today is going to be a research-based task. So a nanoparticle, or nanoscience, is the study of structures that are between 1 nanometer and 100 nanometers in size. Most nanoparticles are made up of a few hundred atoms. Atoms are about 0.1 nanometer in size, so you can see how if we've got something that's between 1 and 100, we can have quite a few of these atoms in there. And just so you've got an idea of the size, 1 nanometer is equal to 0.000000001 of a metre. There is a conversion chart that I quite like giving to my GCSE group, so I'm going to show it in a minute, but it looks a little bit like this, but I'm going to show it on a blank piece of paper just to show you how we have different sizes of units. So with nanoparticles, you can be asked to work out several different things, and they are the order of magnitude, the surface area, the volume, or the surface area to volume ratio. So the first question, a zinc oxide nanoparticle is 32 nanometers in diameter. A zinc atom is 0.28 nanometers. How many times larger is the zinc oxide nanoparticle? Now this is more straightforward than it looks. When I say order of magnitude, it's actually not as complicated as it makes it out on here. So all you would do for this question here is you would say, well, the zinc oxide nanoparticle is 32 nanometers. That's 0.28 nanometers, so this is the bigger one. And I would like to know how many of these would fit in that. So whenever you've got an order of magnitude calculation, if it says the order of magnitude or how many times larger, this is a very standard way they say it, how many times larger, all you would do is you would do the large number on the top, you'd do the small number on the bottom, okay? So if we work that out, 32 divided by 0.28, it is 114 times larger. For question number 2, it's about surface area. So question number 2, I'm just looking to see whether you can actually see what I'm writing. Yes, you can. So a cube-shaped nanoparticle has sides of 10 nanometers. What is the surface area? So to remember in maths, to work out area, I don't quite know how they word it, but you do the base times the height, okay, to work out area. So if we've got a cube and its sides are 10 by 10, we'll do 10 times 10. Okay, so each side is 10 nanometers squared. But we know we've got a cube. A cube has 6 sides. So it's 600 nanometers squared. Right, the next question then, the top bit's just going to go out of view now. So the top question, or the next question, number 3, is a cube-shaped nanoparticle has sides of 10 nanometers. What is its volume? So remember, in maths, to work out volume, you do base times height times length. It's you do the 3 sides, so that's not good because we're looking at a cube, but you would do that times that, and I can't do it, but you times it by its depth, okay? So we need to be doing 10 by 10 by 10. Remember, it's volume cubed. And then the final question that you can get asked is to piece it together and say the cube from questions 2 and 3 has a high surface area to volume ratio. What is it? So for question number 4, just checking you can actually see. Yeah. So for question number 4, we want to work out the ratio. So what it's saying is that we've got an area of 600 and we've got a volume of 1,000. So it wants you to simply work out what the actual ratio is. So what we're going to do, for every one of that, would be 0.6. This is basic math skills. So if you're not fully confident with this, maybe have a little look on My Maths and just check that you're okay with how you work out area and volume of shapes. Because this is expected maths at this level that you know we shouldn't have to be teaching it. If you are really stuck, let it be known to you, I have seen in my entire teaching career 1 surface to volume ratio question. So just let that maybe settle your nerves slightly. It was worth 2 marks, and as I say, 1 question I have ever seen. So if this doesn't make complete sense to you, just leave it, don't panic too much. But as I say, if you're not sure on how you work out area and volume, you maybe need to revisit that on My Maths. So, nanoparticles then. So we know that they've got a good surface to area ratio. We know that they're between 1 and 100 nanometers in size. We know that that's 0.00000000001 of a meter. Okay. So, nanoparticles have much larger surface to area volume ratios than the same material in powder, lumps or sheets, despite being tiny in size. So we can have the same material and we can have it in powder form or we can have it in nanoparticle form. In nanoparticle form, it has got a much better surface area to volume ratio, but it's much smaller. So something to be described as a nanoparticle, it needs to be between 1 to 100 nanometers. It needs to have a high surface area to volume ratio, and it needs to be described as tiny in size compared to the same material in bulk. In bulk means lumps, sheets, powder. Now, all of this information about nanoscience and nanoparticles I have seen a few times. Normally, the questions ask, if something is a nanoparticle, what must it be? So any of those 3 are the correct answer for that question. Usually, the exam questions focus on the uses and risks of nanoparticles. So that's what we're going to be looking at today. That's what your focus is. Everything I've spoken through so far is really rare on an exam paper, but it just puts it into context. They're really tiny, but normally your questions are based on the uses and the risks of nanoparticles. So some of the uses of nanoparticles, medical treatment. So there's a great example of bandages. Some of you, you tasked today's research, but there's a great example of bandages because you can use nanoparticle silver because it's antibacterial to use as in dressings for wounds. But there's a bit of a problem with that because if you then throw that bandage out and it's not properly disposed of, it could then kill bacteria in the environment because it's antibacterial. It's being trialled in the form of nanotubes for medicine, so to deliver medicine. So again, the high surface area to volume ratio, you can get lots of medicine in something very tiny. Cosmetics, certain foundations now use nanotechnology. So yeah, there's quite a few makeup brands that use nanotechnology to improve their cosmetics. Sunscreens, now these were one of the first sort of mainstream uses of nanoparticles. So zinc oxide, which we looked at previously, reflects UV or ultraviolet radiation, which is what causes sunburn. So people that make sun cream realised that they could put it into their sunscreen, and even though zinc oxide is white, when it's in nano form, you can't see it. So they applied it into their sun creams, number one, because then people weren't being left with these claggy, horrible white marks everywhere. But secondly, because it could be spread out over a really big area for very little, so people could use less sun cream and get better coverage. Now, there are some negative side effects of this, because if you're using sun cream and it's not white, you sometimes can't tell where it's been applied and where it hasn't. The other thing, and it comes down to the risks, is there is more concern about how easily the nanoparticles of zinc oxide can be absorbed into the body. So that's something else to consider. Other uses of nanoparticles: electronics and catalysts. So a catalyst is something that speeds up a reaction but doesn't get used up. So quite often big companies will use catalysts to speed up a reaction, to make it happen quicker, to get more product, to be able to sell it, to get more money, but the catalyst doesn't get used up. So nanoparticles make really, really good catalysts. My class in particular, we talked about catalytic converters on cars, if you remember when we were looking at reducing nitrous oxides from car exhausts. That's a great example of a place that uses a catalyst in nanoparticle form. So you might want to have a little look at those. So some of the risks of nanoparticles then. So because they're relatively new science, their impact on health is hard to determine. The long-lasting impact can't be measured yet because they haven't been around long enough. It's a little bit like that idea of smoking was encouraged, and then as sort of technology developed and time went on, people realised that actually smoking wasn't so good for you, but it took a long time to change that. So anything that's new science, they need lots of evidence to back up whether it's good or not. So it's very hard to determine the impact on health because there's not enough time that's gone on. So the big problem, or the thing that people are concerned about, is that they're so small they can easily be breathed in. And there are worries that they can cause reactions to happen in the body because they're catalysts. So because they're tiny nanoparticle catalysts, they might cause reactions to happen in the body that we don't want. And they might bind to toxins due to their high surface area to volume ratio. So people are looking and studying the impact of nanoparticles in the body. However, the risks are minor compared to the benefits of nanoparticles. So sorry that was a little bit more rambly than usual, but nanoparticles are a little bit, it's not quite as clear cut and logical as everything else. It's a little bit of a, this is what it is, this is what it has to be a nanoparticle, these are some uses, here are some risks. Your task today is going to be to research one use of nanoparticles in more detail. There is more information on the PowerPoint slide to help you. If you're really stuck, I have also included a link to a different video that just explains nanoparticles in a different way, so you might want to watch that as well. But yeah, other than that, research today, uses of nanoparticles. Any problems, email your teacher, email me, and I'll speak to you next week. Bye.